Hey, hello guys. Guess what game is this? The famous Kerbal Aero space program. It's not all about space. Seriously, if you think this game is just about stacking up solid rocket booster, you're wrong. With a big bunch of proper mods, you can turn this into a fairly accurate flight simulator. What's better, you're designing and building all the aircraft yourself, which is a lot of fun. Here we go, we're gonna show you what this is, what this mod can do and what this game is capable of. Bear with my English, I'm not really a native speaker. Where is our runway? Here we go. Alright, engine spinning. Throttle up. Under 20 knots, under 30, nose up, positive rate, gear up, turning left. Well, you most likely need a joystick for properly flying, but keyboard most times can do, especially we got trim in the game. I finally found a way to trim, put the trim button on the stick, so that solved a lot of problem. Here we go, we are roughly downwind. Leveling off. Trim the aircraft roughly on cruise. I'm not a perfect pilot, so bear with my flying or my English. Here we go. We are flying with absolutely zero assistance. There's no SAS, no reaction wheel, no thrust vectoring, no FAR flight assistance. We can see a few things about the aircraft. I'm gonna turn the mini HUD on. Okay. We're gonna first try the aircraft shock period response by pulling the stick really quick and hard and release it immediately and see how the aircraft responds to its original trimmed angle of attack. Let's have a look. See, it's quite stable. You can see the aircraft actually fall back to its original trimmed angle of attack really quickly. And of course there's yaw stability. Left rudder, right rudder release. After a few periods, the aircraft go back to the center, although not that quickly. That's why in real life we need yaw damper. I'm gonna reduce that a little bit. Let's say 0.08 maybe. Let's have a try. Left rudder, right rudder. See? Much quicker. If we adjust the yaw damper to 0.1. Left rudder, right rudder. See, here we go. That makes life much easier. Also, we got pitch damper, but we don't really need it on this simplistic trainer aircraft. We're gonna show you later once we go into fighter and everything else. Alright, we're turning base leg, reducing speed a little, and reducing height. Alright, we'll continue the final. There we go, we see the runway. I'm gonna lower my gear. So far I don't really feel much difference between this and the proper flight simulator. Okay, we're gonna add some throttle to maintain our glide slope and speed. Well, we're a bit too low on the glide slope. Of course, it's not entirely accurate because there are certain limitations on the mod, like I don't have a small enough engine, so I can only build a much bigger aircraft, although its behavior feels like a trainer, but it actually lands much faster than every trainer that does. But hey, you learn how to design aircraft quite properly and you learn how to fly. Alright, with proper trim, I'm actually having my hand off the stick. Small adjustment.
300. 200.
Using throttle.
100. 150. 40. 30. 20. 10.
Gentle touchdown and brake. Well, there is a slight problem with this aircraft. If you brake too hard, it might take over, like this. Well, we can solve it easily later. Well, but first thing, after landing, I'm gonna show you how to design and build one of these easy flying aircraft without SAS. And now let's go. And now we're in the space plane hangar. Well, it's not like we can actually build a space plane RSS, the real solar system mod. I'm still in doubt of that, but that can be our ultimate goal, to build a perfectly controllable space plane that actually go out of the Earth's atmosphere. Not the Kerbal one, which is much easier. Everybody can do that. Right, what do we do? Well, let's name it Trainer 1. Right, I got this mod, I think it's called Kerbal. It's a very nice inline cockpit that allows you to put a propeller engine in the front. Of course, we got the original Mark 1 inline, although it doesn't have IVA, you can't really see anything inside. This mod plus another mod called Modified IVA, another mod, it will add a bunch of much better inside IVA props, including a small glass MFD, and everything else make the whole flying experience so much better. Of course, there's FAR that do much better aerodynamic simulation and design assistance. You need MacJab or Kerbal engineer to show you your thrust weight ratio and vessel mass and stuff like that. Everything else, well, B9, Back 9 aerospace mod is quite important. It adds you a lot of different parts, especially engine pack, lots of different engines. Then I have the KX mod that give you a bunch of propeller engines. What's so amazing is the B9's procedural wings mod. Well, there are two procedural wing mod out there, but I prefer this one. You got much more parametric input. What's more, advanced jet engine mod give you a very realistic especially jet engine simulation. It's basically using NASA engine simulator data. And we have real fuel. Rather than having something like liquid fuel, we actually have to select appropriate real-life fuel for the aircraft. Right, that's roughly the mod. That's mainly handy. Oh, we got adjustable landing gear. Of course, you can use the landing gear come from B9, everything. You can tweak your module manager CFG to make them adjustable by tweak scale, or you just use this adjustable landing gear mod. But I did change something. I put the deployed drag much higher in the game, from original setting of 0.2 to mine 0.5. So once you deploy your gear, your aircraft actually drop in LD ratio, the lift to drag ratio, so you can come in a appropriate gliding slope, which is like real life. You don't really need a spoiler on small aircraft. Right, let's get started. First thing first, a cockpit, and then if we want a front mounted engine, we want a propeller engine. We use the Rolls-Royce engine. Of course, it's huge for the purpose we're using, but you can't do much. Thrust limiter is basically based on the jet engine type. I found out it doesn't really work, but if you reduce the RPM, it might actually reduce your thrust ratio in the actual flying. Right, so cockpit, engine, body, think, yeah, Mach 1 universal tail. It's also tweakable. You can have a, straight and raised, but in this case we can use a straight. We need a long landing gear for the engine anyway. So what's next? The main wing, B9 procedural wings. So X for symmetry, C for angular match. Pop it, and we can adjust by pressing J, Juliet K. So 4 meter looks. Let's do 4.5 length. Root of 2. Base of 2. Let's just use a straight wing. Looks big. So what about 1.5? Yeah, that's the reason I like this mod much more than the other procedural wing, because you have much more parametric controls. You know what number you put in, you know what numbers it gives out. So we now add another section of the wing. Reason we don't want one single section wing is we want a much better looking aileron rather than a whole span aileron. If you press J here, it will have an option for you to match shape, match width, match edge, whatever. And we can reduce the tip width to match the root. 1.5. Give it a little bit adjustment. We can get rid of the trailing edge. Of course, much shorter. Let's say 2 meters. Well, for now, we don't really know what's gonna go on later. If you're really fussy about things, I doubt FAR actually use this to calculate drag and everything, or lift, but for the sake of, well, closer to reality, we are gonna reduce my tip thickness. So now it looks better. So thicker root cord and thinner tip cord. And ailerons. It's not always matching up. Might take a few adjustments sometimes. That's definitely not working. Right. Here we go. Right, let's first make sure if tip is actually tip. See, it's wrong, so we need to flip it. Here we go. So tip matching 0.12, root 0.16, length 2 meter, and adjust. Right-ish location, and we reduce the width so we can match the other inner part of the wing. Here we go. That's our wing with aileron. Okay, and what B9 also add, I think this is a very amazing thing. We can have wing fuel tank. Look at that, we can contain huge amount of fuel, although we never need that much. For trainer purpose, especially if you want a low takeoff and landing speed, we just need a little bit. That's one thing. We don't really need monopropellant. First thing first, disable reaction wheel because that's cheating. And that's about it. Another thing is to reduce the mass strength. If we are just designing a trainer stuff, 0.5 is more than enough. If you're designing a larger aircraft, you might need the setting of 1. If you want a fighter and high G, high speed, you definitely need more than 1. If you want, that's the wrong thing. If you want a large civil aircraft that's very heavy with an engine mounted on the wing, you might need to set it to 2 on the root chord region to give enough stiffness. But for now, we just need 0.5 for a small trainer. Right, before we pop on the tail, I'm gonna show you what FAR is capable of. First thing first, well, we're not really interested in beyond 12 degree. We're gonna just sweep 0 to 12 degree angle of attack. See, we have a curve. Double click. We have a curve of lift coefficient, drag coefficient, and LD ratio. But those are not the most important. The most important is actually CM curve, the pitching moment coefficient. Now we see it has a positive slope, so that means the aircraft is unstable. So as you increase your CL, your aircraft actually gonna pitch up to have higher CL. That means the aircraft is unstable. We need to make the CM curve to be negative, to point downwards for a stable aircraft. How are we gonna make the aircraft stable? Well, two things. One is adjusting the aerodynamic center. The blue ball shown here is the aerodynamic center. Well, the orange game shows you center lift, but FAR actually use this to present aerodynamic center. And we have center of mass, or center of gravity of the aircraft. If we actually make the blue ball to be behind the yellow ball, the CG area, the aircraft will be naturally stable. And how do we do that? We either tweak the CG or we tweak that. From, of course, everyday experience, we know aircraft need tail for stability and control, just like the Aero, right? So we add a tail first. I'm gonna just cheat and use this section. Maybe I will put it here and copy one section and tweak everything before I put it on, because it's much easier. It doesn't work on tapered part very well. Right, length 2 meter maybe, and width 0.25375, and we can rework the aileron, which will be our elevator. Here we go. That is our tail, roughly for now. And we see immediately after putting on the tail our aerodynamic center change, which will put the aerodynamic center to behind the CG. Our aircraft will be stable. Evidence will show on the graph like this. See, our CM slope is actually going down, which means the higher angle of attack we have, the more pitching down moment we will have. So the aircraft will naturally want to stay in the right angle of attack. We trim that, which is vital for manual control aircraft. For fighter, different story. Alright, and we'll see we have CL of slightly over 1, LD nearly 15, but FAR doesn't do it very properly at this version. I don't know why. We will get a better one maybe in the future. Also, this FAR model is actually modified or improved by Honeyfox. Have some tweaking on better flap support. We'll show that later. I don't really need flap in this aircraft yet, because this is just a simple, easy flying aircraft I'm gonna show you. For two purposes, for two characteristics we want for trainer. One, the aircraft had to be very stable, very controllable. Two, we want the aircraft to land slow. How do we do? Land slowly? Well, never mind about lateral stability yet. We haven't put on the vertical stabilizer. But what we want to know is how slow it could land. Or if we see level 1G flight, if I reduce the Mach number sweep here, see 0.2 of a Mach number, our aircraft can fly at 68 meters per second, which is still really quick, but we're flying at 5 point something degree angle of attack. If we use 1.8, it doesn't work anymore. I don't know whether it's FAR issue or I think it doesn't really fly on that angle of attack. I don't know, but well, it's good enough. Nearly 65 meters I fly this degree, so it might be able to touch down, landing approach on, I don't know, 60 meters per second or something. We'll see. But for the sake of training, let's just aim at 65 knots at touchdown speed, which is fine. Right, here we go. Now we're gonna put up our vertical stabilizer. I'm gonna cheat again. I'm gonna put on one of these. Oh, see, the bottom and top surface is different, but it's easy to adjust. I love this menu. Just love this tweaking. Now we have a vertical stabilizer. If you don't like the pitch or the sweep back of things, we can tweak a little bit. But then we need the rudder to be adjusted accordingly. Easy, easy. Right. Oh, hang on. I need a flip. Yeah, that's right. Right, that's roughly our aircraft. Now we need to know how good it is. I have a few tricks that help people make much better flying aircraft. One, of course, is the powerful and amazing derivatives, and FAR is helping us by putting colors on. If it is green, it's great. If it is red, not so great. So we know what's going on. Right, if we put on Mach number 0.35, roughly our normal flying speed, there is a little change in roll right angular acceleration to side slip. If you have a slight dihedral, that will solve this problem, but we don't really worry about that effect. But because spiral mode, it's much less of an issue for pilot rather than Dutch roll. We are scared about Dutch roll much more than spiral mode. I will explain them later. But for now, we see most important thing: CM curve negative, not too negative. Our aircraft won't be very stable, so we want to do either adjust the wing for the CG to shift forward, or we tweak bigger tail, or we tweak other things to achieve that, but the easiest way is always shifting the wing. Thanks to Squad, we have much better editor options, but I found this you need to get rid of angle snap to tweak smoothly, otherwise it will change a lot. Here we go. But when you click it, oops, hang on. But there is a little problem. Once we put it on, if we have the offset menu, the aerodynamic center actually got calculated wrong. It actually changed, but well, from a few try and error, we'll get it. See, A does help. And if we shift more backward, we'll have more stable aircraft. You don't want the aircraft to be way too stable because then it's too springy in the control. Roughly, I don't know, 0.3 to 0.4 value here to 10 degree will be alright-ish. Another thing for the aircraft is on many reasons. One, we want the aircraft to have shorter, lighter landing gear and everything. We want to shift the main wing down. It used to be a hell of a job, but with offset tool it's much easier. Of course, we don't want the wing to be attaching in the air. We want the wing actually to match, so we shift it in a bit, up a bit. Something like that. That will look awesome. More like a real aircraft. And we go to rotate menu. What do? We want the wing to have a roughly 4 to 5 degree installation angle so that when we are cruising or landing, we don't have to pop the whole fuselage up. That will reduce our drag from the fuselage, and also we can have more view to the runway when we're landing, right? Okay, that's roughly alright, if not too much. And we want the tip of the wing to have slightly wash out, so we always have the inner board of the wing stall first. But don't wash out too much, so we will lose a lot of lift on the wing. I know it looks ugly with the, the gap and everything, but who cares? Right, if you don't like this gap of the wing, you can raise the wing a little bit. Oops, shit, sorry. Apologize. Things happen. We need to shift the wing again. Right, more down. If you don't like the gap, you can slot the wing inside a bit, up a bit. That looks alright. Okay, as we shifted the wing up about 4 degrees, we might see the aircraft actually stalls on 12. Everything changed, but it doesn't matter, you just reduce to 10 and see what's going on. But remember, although it says your aircraft nose is at 10 degrees, your wing is actually on 14 or something, so don't be scared about reducing your angle of attack. Doesn't matter. But we still have a negative slope, so it's alright. We can fine tweak it. Aircraft design is always about lots of iterations, so don't worry about it. Now we have fuel, and if we change the fuel, we'll see, okay, CG doesn't change much. That's the advantage about straight wing. Now we put landing gear on. Adjust for landing gear small. Get rid of angle snap. That makes life much easier. Right, something like that. Something like we want the aircraft to landing gear at least 45 to 60 degree. 45 is maybe a good number, so you don't want the landing gear to be too much inward. And its angle, don't worry about it yet. We put the nose gear first. Well, this is not really center symmetrical, so we use a 2-wheel small landing gear. Get rid of symmetry, get angle snapping so it sits on the center. It will be too much to the back. What do? We swap it. We rotate it somehow. This key. Okay, here we go. Here we go. And we can use offset key, get rid of angle snapping, shift it more forward. Oopsie, you will see it's way too long. What do? Adjustment show. Wheel height and everything, you can't really adjust it, but we can cheat a bit, have offset key to shift the whole thing up. Yeah, we could also use tweak scale, but I doubt it will work because they might, modes might conflict with each other. But well, this will do for now. Later, all our aircraft will be considerably bigger, so we don't need to run into this problem again. Although I have a problem now, I can't really tweak my landing gear anymore. I can't click it anymore. Okay, I can adjust it like this. We want to enable steering. Much stiffer spring, so we don't want the nose gear to dip down when we brake hard. Slightly higher damper. That's about it. And that's on. And well, look at the landing gear. That doesn't look nice. We go to options. There'll be a where is it? Alignment guide. Show you the angle and everything. Right, so we go to rotate, get rid of angle snapping to rotate it to horizontal, and we use shift to shift it up so that it's roughly, if not slightly shorter than a normal gear. Of course, we will have it pop up on the wing. That's the problem of mod we have. We can't really do much about it. Right, if you think the nose gear doesn't have enough protection to the propeller, we can have the nose gear slightly longer. That's alright. Imagine if we can do tweak scale about the landing gear, that'd be much nicer. Right, that looks alright. And one more thing, you want the touching ground point of your main landing gear to be at least 15 degrees to the back, drop down 15 degrees to the back of your CGs on any fuel or payload conditions, so that your aircraft don't tip over on the ground when you're taxiing or landing. That's almost critical. You don't want the aircraft to, you don't want to load the aircraft and the first thing is your tail is touching the ground because your CG is so much back compared to the landing gear. But well, so far so good. It looks alright. Now most of the systems is set on the aircraft, and we can adjust something else. Right, we have a little bit of chamfer or something. I think it's tilting inward a little bit, but we can have auto align wheels button, but doesn't change much. It should be fine. We turn off. I clicked something wrong, but it doesn't matter. I need to select my landing gear somehow. Here we go. Key height adjustment. Turn off alignment guide. Redo FAR. Okay, we still have stable slope. If you think it's slightly too not stable, you can adjust it. If you think it's alright, leave it. You can always do a few flying to see whether it's actually okay or not. Our major issue is now not only the slope, but you need to see the intersection of the CM curve to the 0 point, the x-axis. Where it intersects, that means the aircraft will be trimmed on that location. Currently the aircraft is trimmed to be so much nose up. It will be trimmed at 12 degrees or something, which the aircraft already stalled. We don't want that because our tailplane has a big angle compared to the main wing because we rotated the main wing, right? So we want to rotate that a little bit as well to have less nose up moment. See, it changed. How much we want to rotate? We want to rotate it to, yeah, roughly here. See, our aircraft will be cruising at roughly this area, which the main wing is about 3 to 4 degree angle of attack. where the nose is roughly 0, tail, the aircraft is naturally trimmed on roughly 0 point, so aircraft is naturally trimmed on cruise, which is awesome. And what we want to see next, what about full elevator? Oh, before that, I need to do something else. We map each right channels of control onto right things. Aileron only control roll, and at, let's say, 8.5 degree-ish. We don't want the aileron to be too effective for trainer, especially if you're using keyboard. And pitch, well, let's put it on 14.5 for now, we'll test later. And this only for yaw, and 10 degree maybe for now. Right, let's see. Right, let's put pitching setting to full pitch up. You will see, oh, I'm actually capable of trimming my aircraft to be way beyond stall. That's dangerous for, you know, especially using keyboard, so you're gonna reduce your deflection. If you're using joystick, don't need to worry way too much. But if you're using keyboard, you might want to be careful about this. Otherwise, you're gonna pull your aircraft into a stall. Of course, we don't want too small angle because we might not be able to pull the aircraft off the runway. Now we have a slight problem. The angle is way too small, but the before we trim the aircraft way over nose up, that means we don't have enough stability. Aircraft is too much, too much towards neutral stable. That means a small deflection of elevator will pull the aircraft into a large angle attack. What we do, we shift the wing backward even more and see the stability higher, right, and slightly more. We are a trainer aircraft, don't be afraid of having more stability. It's easier for you to fly. Of course, our trim, cruise trim is off, so we need to adjust here a little bit. Slightly nose up, slightly more nose up. Yeah, that should be alright. And now we will see, as we have much higher stability, we will see, yes, it's roughly on the point. Can have a slightly more, 12.5 degree might make our aircraft stall. So we need to reduce that a bit. 12 degree, bad. 9.5, small. We want something 10, 11. Try 11. Yeah, 11 looks alright. So that will make our aircraft fly well, and we double check derivatives. 0.35, 0.3. See, we have a slightly red here. If you see anything red on longitudinal derivatives, you are in deep trouble. But if you are having a lateral, it's not necessarily always bad. But we have to solve it, right? We solve it by having a dihedral. The aircraft might not be stable enough on, roll right acceleration by side slips. That means if we have a side slip to the right, our aircraft actually want to roll to the other direction, which is not stable, and we want to change that. What do we do? Have a rotation of that, or the whole wing, but as we have landing gear, we might not want to shift the whole wing. We want to have the tip pop up a bit. Oops, that doesn't solve the problem. Right, let's try shifting the whole thing. Or another possibility is we have way too small vertical tail. Not likely the case. Let's try a little bit dihedral here. It reduced a little bit. It reduced even more. So I'm gonna change the tip bit into original. That's weird. Right, we most likely need a much bigger tail for our wing. The tail size compared to the wing is way too small, but that's relatively easy to change. Let's press J. Slightly longer, slightly bigger root. That is slightly longer. And we match it. Here we go. Let's do again. And that is weird. Another thing you can try is having your tail section slightly dihedral. That will get rid of your yaw right angular acceleration to yaw right rate. So if you have a yaw right rate, you should have a yaw right acceleration, which will make your aircraft easier in handling and stable in flight. But these L beta is very, very weird. Well, but it's not a big issue because our aircraft is now unstable on the spiral mode, which is much less of a problem. I'm gonna put my main landing gear. Well, I'm gonna try the auto align wheel button. Don't really work. Alignment guide. Wheel angle. Almost 0. 0, 0. Almost in every axis. That's good. Right, I think the aircraft is ready to fly, although we have a slight problem because our CG is higher than the wing location. It might... Hang on, I'm having a big issue here. My CG is not in the center. That's probably what's causing the problem. Who's causing that problem though? The wing? Ah, unsymmetric fuel tank. That's funny. Two fuel tanks are not in the same size. Removal tanks. Full tanks, 1476. Ah, now it's equal. But the CG is still not in the center. Ah, it's definitely something on the wing. Don't worry, we'll find the problem. Ah, now it's in the center. I think one of the mod is playing weird. But hey, what can you do? This is, we chose to have so much mod, and of course they will have problem. Just have to face it and solve whatever, you know, is happening. We don't have the installation angle anymore, so we have to twist our tail again, the wing again. Well, now we have alignment guide on the wheel to guide us, so we know where it was before. Ah. Here we go, and here we go. It works because our CG is in the center now. The aircraft is stable in many ways, and we just need a slight dihedral here to get this grain, all grain. Perfect. Sweep AOA. Now I know what's going on. The wing, yeah, we don't have enough stability, so we have to shift the wing back again. Number 2. Okay, that looks alright. Aircraft stable, trimmed in slightly. A bit more. Here we go. Landing gear slightly more to the back. We need to shift the landing gear a tad more forward, so we don't need the too much authority to pitch up. Right, do it again. Right, still stable. Pitch rate, pitch setting. See, we have a more stable aircraft. We need more deflection, which not necessarily is a bad thing. Oopsie, 13.5. I think that looks perfect. And who's want to fly this? Of course, I'm gonna reduce my fuel quantity. Right. Right. Let's see. 0.2. Flight 1 point something degree of the nose. Wow, that's awesome. Right. Checking last time. Pitch setting and trim setting. I think we can fly now. Let's try it. We have throttle a little bit because there's a glitch in Aero advanced jet engine. If you start your engine on 0 throttle, it will cut off again. Right, let's go on chase mode and go inside, start the engine. Of course, parking brake for now. Got HSI, found our own runway, and everything ready. Now FAR out, flying time, brake off, full throttle. Okay, we can see a surface thrust weight ratio 0.1718. As we speed up a little, the aircraft will have slightly higher thrust weight ratio. 0.3 is what you need for a trainer anyway. More than enough. Alright, we are at 100 knots. We'll see the pitch. Oh, we actually pitch up. We're actually leaving the ground at 110 knots. That's a pretty nice low speed. We're turning left slowly. Good roll response. Full right roll is a bit slow, so we can adjust later. Reducing throttle a little bit, still climbing, still speeding up, 142 knots. Gear up. We'll see our LD ratio suddenly pop up because the gear is actually having a lot of drag. Right, reducing throttle. On downwind, we're gonna trim the aircraft.
1,000.
Alright, kinda trimmed. I'm gonna try the short period again. Whee! It's pretty good, eh? Back to level flight. Another one. See, the aircraft is very stable, very easy to fly. Nose down, nose up, good response. And I'm gonna try yaw with knock damper, left rudder, right rudder. See, very little Dutch roll effect. And you see the damping of the natural vertical tail is not big enough. Okay. For the wing side, we don't have, although it looks big, it's not that big. That's why we need a yaw damper. With the damper, it will improve quite a bit. See? Right. And now we turn back and try our landing approach. Basically, I think it has amazing handling. We can say goodbye for SAS if you design a good, proper aircraft. Very good turn rate. Very, very good turn rate. Okay, we are way above the glide slope, but no worry, we have a really draggy landing gear. Roll is definitely too slow. We want a better roll. Landing gear down. And check our speed. It's now reducing. Our LD is only 7 or 8, which is alright. Trim the aircraft nose up a bit.
1,000.
Still slowing down. I love the draggy landing gear, which allow you to properly approach and land Otherwise you will have an infinite glider.
500.
500. Aircraft change.
400.
I think we can touch down at 110 knots, although this is not a really established approach because we are keep on dropping speed rather than a stable speed, but who cares?
50. 40.
30. I'm gonna hand a bit.
20.
Hand a bit. 120 knots.
10.
115, still hanging there. 110, touchdown. Wow, this is amazing. Very good flying. Full brake, let's say the stability. Still have a bit of going left and tip over issue. I think it's mainly because the torque of the engine coming as well. But who cares, it's alright. Bonus video, I'm gonna show you the funny glitch of the advanced jet engine so far. Say if we do a proper checklist while we're starting the engine, first cut down your throttle to 0 and have your parking brake on. Cockpit engine start, and, you know, checklist blah blah blah, flap setting, trim setting, whatever, you got everything ready. And engine start, looks alright, right? And we release the brake and to infinity and beyond, and that's what happened. Oops. Well, thanks for watching, hope you enjoyed this video, and I hope advanced jet engine solve this problem soon. And more video will come until we actually made the SSTO go out of the Earth atmosphere. Thank you for watching.